HiwayCAD mode? Surviving the AI surge.
Only data chains enable professional collaboration. Only network versions enable virtual reality. In the global engineering field today, a fundamental revolution regarding design tools and collaborative logic is quietly unfolding, as generative AI achieves startling maturity in image processing, rendering, and facade generation. Traditional design modes centered on standalone software or isolated disciplines are rapidly losing market competitiveness. This shift is more than a technical iteration. It is a reconstruction of industry survival logic. Faced with the overwhelming impact of AI, the future of engineering design lies not in competing for drafting speed, but in building a mode of complex logic through professional integration. This integration manifests in the deep application of building information modeling BIM, which consolidates architecture, structure, construction, plumbing, HVAC, electrical, and full process cost estimation into a unified, real-time digital ecosystem. 3D modeling technology is now highly ubiquitous and mature. Non-specialized public AI models can already generate high-quality renderings and elevations via simple prompts, threatening the survival of junior designers reliant solely on drafting skills. The global BIM market is projected to grow from $9.03 billion in 2025 to $15.42 billion by 2030, a compound annual growth rate of 11.3%. This drive comes from an urgent need for real-time collaboration and multi-stakeholder coordination rather than better rendering. Roughly 12% of total costs in large-scale global construction projects are spent on rework caused by design coordination errors. AI often amplifies these losses because it produces beautiful visuals, while lacking a deep understanding of underlying engineering logic. While AI excels at small tasks like copywriting or local drafting, it fails at complex, cross-disciplinary major projects. Due to its inherent randomness and lack of physical common sense, engineering is a rigorous science. The same prompt run through and AI can yield vastly different results. A level of unpredictability that is intolerable in engineering. To outplay AI, the only path is professional integration. Software must integrate architecture, structural mechanics, construction organization, fluid mechanics, electromagnetics, and economics. This creates a high-order logical closed loop, where changing one variable automatically updates all related professional parameters, a feat currently beyond the algorithmic black box of AI. The traditional linear workflow, where the architect finishes first and others fill in the frame, is an efficiency killer. Collaborative disciplines often find architectural flaws like excessive spans only late in the design phase, making changes costly. If a structural engineer rejects a plan, the architect must restart, triggering a manual update across all disciplines that is prone to human error. HiwayCAD 3.0 network version proposes a different logic, shared models, rather than distributed drawings. Based on cloud computing, all disciplines work on a single database. If a structural change is required due to seismic calculations, the architectural model receives instant feedback. This real-time collaboration reduces project delays by over 20% and identifies conflicts early through automated clash detection. Paperless design is a necessity for managing modern complexity. For massive projects like airports or skyscrapers, physical drawings are so voluminous they become a bottleneck for storage and retrieval. HiwayCAD 3.0 leverages VR and AR to achieve its paperless goals. One-to-one visualization. Personnel can observe complex layouts at a one-to-one scale in virtual space, providing clarity to drawings cannot match. Using virtual mockups instead of physical ones can save tens of thousands in material costs. Designers can enter virtual dead zones to observe hidden layouts, surpassing the capabilities of physical models. Traditional construction relies on negotiation, documents text-based patches to the design when site realities differ from plans. This often leads to a mountain of paperwork and a disconnect between the original design and the actual construction. In the modern full life cycle approach, changes are made directly in the digital model, ensuring the drawing matches reality. As the geometric model changes, the bill of quantities and cost databases update automatically. Settlement becomes a real-time reflection. During construction rather than a post-project reckoning, inaccurate cost estimation is a breeding ground for financial risk and corruption. Traditional methods often use crude multipliers, for example, a 1.5x buffer, to cover uncertainties. By linking cost information to geometric objects, BIM 5D can increase the accuracy of cost forecasting and reduce overall project expenditures by approximately 12%. This is the technical holy grail for ensuring economic benefit and preventing corruption in large-scale projects. While the current economic climate is cautious, 46% of construction technology investment in Q1 2025 flowed into projects that deeply embed AI into core engineering workflows, totaling $35.5 billion. Capital is moving toward empowering AI rather than replacement AI. The era of simple 2D or 3D CAD is over. Only software that grasps project holism, professional integration, and full lifecycle management will thrive. Even a century from now, current generative AI architectures will likely struggle to meet the rigorous scientific and logical demands of engineering design. For elite design institutions, the path forward is clear: professional integration, paperless workflows, and refined cost control.